All right, guys. Well, thank you. So, as I said earlier, I was in an earlier session. Not many people turned up. Thank you to the three guys. If I had some prizes to get out, I think you'd all get one. It's kind of tough, as I know. When you're on the last day of a conference and it's the afternoon and the World Cup is on, and there's probably more important things that you have to do than attending conferences. So. All right, so I think this session is not going to last the full time. This gentleman, Christos, was supposed to do this. Unfortunately, he couldn't because of business commitments. As you can see, he's a lot more handsome than I am and much more smartly dressed. And he's the Director for Solutions Architecture at GridGain in EMEA. So he could have actually brought a lot to this presentation because he works with clients and customers exactly on the kind of problems that they deal with. But sadly, you've got me. So hopefully I'll do a reasonable job. And all right, so just a couple of quick slides about me and my background, and then we'll dive straight into the microservices. Okay, so that's me, Akmal Chaudhri. And so in terms of my background, if anyone attended the earlier session, I think a couple of you guys might have done. So, old guy, gray hair, white hair, no hair. Basically done lots of things in my IT career. Started life as a developer working for Reuters in London, real-time systems, relational databases. I was an academic, a whole lot of other things that I worked on, big data space. Two bullet points there that I would draw attention to. The very first company I worked for, Reuters, so very interesting. So they worked, a lot of real-time applications, and my first 8 months there were the worst 8 months of my life because they got me working on these horrible old systems using PDP-11s, 8-inch floppy disks, switches, and all sorts of, archaic technology. And I thought, as a fresh graduate, I'm going to work with the latest and greatest technology, and I'm going to be working with fabulous new skills that I'm acquire. And then after 8 months, I realized why they made me work on these old systems, because they have business value. That's the key thing. These systems still have to be maintained. Someone has to love them. Someone has to look after them. Someone has to enhance them. And I think this is often forgotten in life. And then one of the things, of course, that we can do today is that where it's not possible to re-architect systems because it's too expensive, perhaps the use of things like services, microservices, is a way to address some of the challenges of the modern world in terms of resources and, it's money, people, time. It may simply not be available. The other company I would just draw your attention to is I worked for Informix as well. So I was very privileged because at Informix I worked for Mike Stonebreaker. So if you know anything about databases, Mike is the guy who helped develop Ingress, Postgres. These days, it's SciDB, VaultDB, Tamer. Very prolific academic as well, based at MIT these days. So he publishes a lot, all these prestigious conferences, SIGMOD, VLDB, IEEE Data Engineering. And so it was a very interesting experience there as well, because again, you get to see that the world has kind of moved on, whereas historically, especially in research in relational systems, we used to talk about monolithic database systems, one size fits all. So whether you use Oracle or DB2 or Sybase or something, it's going to address a wide range of problems. And typically that's true in many cases, but today if you look at how the database technology is kind of evolving and emerging, so there is this case even with the research that Mike has done, for example, where you've got systems like Vertica, for example, designed for slicing and dicing vertically, being able to look at data in a different way. Or you've got memory-based systems such as VaultDB is another one of his projects. Very much the case that you do away with a lot of the baggage that comes with relational systems. You're developing for in-memory, different problem, different technology. So, that's the nature of things. Lots of experience in a variety of technologies, some publications as well, and I when I started out at GridGain about a little bit over a year ago, my boss, who's Dennis Magda, Dennis is the PMC for Apache Ignite. That's the technology we're going to talk about today. He asked me to write some articles because I knew nothing about in-memory data grids. I never heard of Apache Ignite. And so I took the opportunity really to start writing things over time and just share what I learned with others. Initially, many of those articles are very basic. They just cover the different sort of components of Ignite. Subsequently, they've become a bit more technical, especially this year as well. So we're talking about things like failover and recovery, transactions, more recently, genetic algorithms, machine learning, this kind of thing. So have a look at that in your own time if you would like to do so. Okay, so let's switch to this presentation. Okay, so there we go. So Ignite, okay, so I'll cover a little bit about what it does, and my apologies to those of you who've already heard this message. And we'll talk a little bit why it says, backbone of your microservices-based solution. So Ignite has a services grid, what's something that it's had for some time. And the thinking is that it can form the foundation of microservices, if that is something you want to do. And we'll look at some of its capabilities and some of its features. And again, there is a demo towards the end just to show you what you can achieve with this. And so in terms of agenda then, so cover a little bit on the service grid, and then we'll look at the principal components of Ignite. So there are things like data nodes, service nodes, what's the intercommunication between them. You can interface using a variety of APIs from external applications, okay, who may know nothing about the implementation. I mean, this is typically what you want to do with services, okay? You hide the implementation, you expose some interfaces, and then applications can talk to those services. And persistence might be important as well. So this is something that they added to Ignite last year, so it's got its native persistence capability. It can also read and write from external third-party systems, whether it's a relational database or it could be a NoSQL database or something else. Okay, so have a look at the service grid in just a moment. Just a high-level overview, just to give you some kind of perspective on what Ignite is. So started life as this memory-centric storage, okay? So go back in time, 10 plus years, when GridGain, the company, was founded. So they are one of the sponsors today. And they developed an in-memory data grid. And there are other products out there, some of them commercial, some of them open source. So you might be familiar with things like Oracle Coherence, for example, or Hazelcast. These are commercial offerings. And over time, especially this last year or so, they've added more features and capabilities. So it's not just a caching platform. Originally, it was designed to address two main problems. One was scale, and the second was performance. So these can be achieved by really adding additional resources to your cluster, adding more nodes, you get more processing power, the ability to store more data in the cache. And so originally for third-party persistence, okay, so Ignite can work with third-party database systems, as I said, relational, very well. If it's a transactional system, we'll cover that in just a moment as well. But equally, HDFS, NoSQL can be used. On the landing page at the Apache Software Foundation, which is ignite.apache.org, in the top right-hand corner, there is a link which says screencasts. Okay, so if you drill down, and at the bottom of the page, you will find 3 videos which essentially show you how Ignite can interface with a relational system. In the demo, they use MySQL. But basically, what it shows is the series of simple steps that you can do to create a project. And then what Ignite can do then is once you've put in your credentials and the IP address and the port number where the relational server is running, it will connect to that and it will manage that for you. So the consistency of the tables that you've asked Ignite to manage for you in the database system, and as well as the cache that it has, they will remain consistent. So changes in one are reflected to the other, and vice versa. So this is a very useful feature. So sometimes in business, as I said, it's not possible to get rid of existing technology. You've invested too much time, money, there is business value there. So the thinking is that in this case, it makes sense to keep what you have, but perhaps enhance it somehow to be able to address new types of problems, or maybe there are some queries that are not performing well, for which cluster computing could be a good solution. So last year, they added this native persistence capability. So now Ignite can behave like a distributed database system. It can save state. It can save the data. It can be your system of record if you want it to be. And on top of that, then you've got a number of different interfaces. So SQL is one of them. So there has always been some level of SQL support in Ignite. But last year, particularly, the effort was to try to add SQL 99 capability, which is now there. And so that can work on cache. Okay, you can run SQL queries on the cache, and you can run it across the native persistence as well. Key value interface. Yes, question.
So I understand that there are many parallel RDBMSs. I understand that there can be many parallel RDBMSs.
Yes.
And so if I update data, these nodes have to synchronize, is that?
Yes.
So they will.
Yes. So typically, the way that so if I can repeat the question. So the gentleman was saying that we do have parallel database systems around today. There are other products that can do this. In this case, the issue then becomes in a distributed environment, about updating data. You want to ensure that you get a consistent view of what you're storing within the large sort of cluster space, if you like. And so with Ignite, and I think this is fairly true of most distributed systems, that each node manages a part of the overall data. Ignite knows what part that particular node is able to store, because being a key value store, we just apply a hash algorithm to the key, and there is an address space that's available based on all the nodes that are part of the cluster, and therefore it knows straight away which node will store this particular part of the data. And typically then in a distributed environment, we don't just keep one copy, because if we lose a part of the cluster, that data disappears. It's no longer available to us to query. So normally it's fairly typical to have at least one backup copy. Sometimes you have additional backup copies distributed across your cluster. So in the event that one node or two nodes or more go down, backup copies can be used in order to perform sort of queries. That's fairly typical. Oracle have, of course, parallel database system. There are other manufacturers out there that have sort of a lot of expertise in this area. And if you look at the way they do things as well, it's very similar in terms of allowing you to keep replicas, backups, across the cluster in the event that some part of your system goes down, which if you're using a very large cluster is fairly typical. I understand if you look at Google, for example, and they use a lot of commodity hardware, typically some percentage, I don't know what it is, 5%, perhaps it may be a little bit too high, of those machines go down periodically, okay? They'll lose a part of their system. But because they've got enough replicated data, we don't notice it. We never see that problem because there is some inherent copying of data around the cluster. In theory, you could copy all of the data from every node to every other node if you want. That's overkill, and that's going to involve a lot of network traffic as well. So normally, I think you don't do that. If it's small amounts of data, that might work. But for mission-critical systems, I think typically at least one backup of the data, possibly another one, depending on how important the data are to you, that would be fairly normal. I hope in a roundabout way that's kind of answered your question. So, sorry for the long-winded answer there. Okay, great. Okay, transactions. So Ignite doesn't do just caching, it does transactions as well. And these are both ACID transactions, okay, locking, and lock-free optimistic transactions. And so these can be important because it will ensure that the system moves from one consistent state to another consistent state. All right. So just to give you, and again, my apologies to those of you who heard this story before, but earlier this year, I'm a great fan of MOOCs. I like these massive open online courses, EDX, Coursera, and others. And I happened to be on the website of one of these vendors, and I decided there's a particular course. I'd like to pay money for that because I want to get the certificate. So I fill in the details, put my credit card details in, hit the pay button, and it comes back and says, there is an error. And I didn't think anything of it. I thought, okay, there's an error, no problem. My card hasn't been charged. Sometime later, I look on my bank statement, and I notice that the bank has charged me. So that has appeared on my bank statement. I go to the vendor, the merchant, and tell them, and they say, we haven't received the money. All right, so where's the money? Who's got it? It's my problem now to sort this out. So the merchant hasn't received the money, the bank has charged me. This situation should not occur. It's inconsistent, okay? So either the transaction should have completed correctly, I should have been charged the amount of money, and it should appear on the merchant's website that, yes, I've paid for this course, or it should not. There's no sort of middle situation. So there's a poorly designed system. So Ignite can, with its ACID capability, it can prevent this kind of scenario because the system will always move from one consistent state to another, okay? So these transactions, cluster-wide if necessary, but obviously, you need to think about how this is going to impact performance. If you're going to be accessing lots of data, updating lots of data, all of this could tie down resources. Other things, so compute grid, leave that aside for the moment. Services, okay, which is what we're going to talk about. It can do streaming as well, okay? So it doesn't do streaming per se. It's not a streaming engine, but it can integrate with streaming technologies such as Spark streaming, for example, or Flink, or even technologies such as Kafka, for example. If you're working with those type of products, there are connectors and adapters for these technologies. So it can take data in, act as a sink for these sources, then you can process the data locally in Ignite. And they've added a machine learning grid as well. So it does linear regression, clustering, k-means, all of these types of capabilities. And of course, lots of vertical examples. So if you have time, I would encourage you, have a look on the Apache website. So specifically then for microservices, then we believe that Ignite Service Grid, which has actually been around for a little while, can actually form a good foundation. And there's a couple of different capabilities that it has, and we'll go over and discuss these in a bit more detail. So we could have, for example, a cluster-wide service. Maybe we're generating some kind of counter, and we only need one instance of that. We don't need multiple counters being created. We need to go to a single source that gives us a new counter, or perhaps some kind of ID generator, perhaps for particular customers or products or something like that, which have to be unique. And therefore, there's an example of a singleton, where we will create a single service cluster-wide, and it may be running just on one node. But we have the flexibility to define that service in such a way that in the event that, say, the node where that service is running goes down, Ignite will launch that service on another node, okay? We can configure it to do that. Another example is where we might have a node singleton. So perhaps we have a service, one service that runs on each node in our cluster. That might be possible as well. I can't think of a good scenario where that would apply, but certainly that's possible, okay? So we can do that. So node singleton. Now, because it's cluster computing, Ignite can do all of the things such as load balancing, fault tolerance, okay? So it can ensure that resources are being utilized to the best based upon what is currently available. If parts of your cluster go down, again, it will take care of the load balancing for you and give you the ability to continue working. And as you're adding new nodes as well, again, that will come into play in terms of load balancing and fault tolerance, okay? So inevitably, in distributed systems, it's often the case that resources go down for some reason. Maybe it's a hardware problem, perhaps it's latency, perhaps it's just communication. The network is down, but the machine might still be working, but we can't communicate with it. So there's a whole range of issues that we have to deal with because building distributed systems is hard. I mean, that's why it's taken us a long time to get where we are today. But a lot of these cluster computing concepts, such as two-phase commit and other things that have been around for some time, we can utilize these to help us ensure that we get some level of consistency. In terms of deployment then of these services, then how can we achieve this? Well, we have this capability, this node filter. So we can specify exactly what sort of service node we have, where that service is running, and there is some configuration options that I will show you very shortly where we can do this. We can also define some interfaces, okay? So if, for example, we are using Ignite to run some services, but we have external applications that want to connect, there are some well-defined interfaces that we can use, okay? So they will know exactly what operations they can run. Excuse me. And then sticky versus non-sticky. So sticky is we're saying, okay, this service is going to run on this node. Exactly. And then non-sticky, just leave it up to Ignite to decide where it's going to deploy that service. Okay, that gives us much more sort of flexibility. So that's really the issue there. There's a whole range of other capabilities as well, which we're going to cover in the subsequent slides as well. So the main thing is that I don't know if some of you are able to attend the last speaker's presentation. Did a very good discussion of services and microservices in particular, and some of the sort of demands that you have in terms of performance and, you know, what is a microservice? You know, how large is it, for example? You know, how do we define it? It's not very clear. So here we believe that regardless of what it is you are trying to define in terms of microservices, you know, with sort of small units of work that you can call, and we can chain these together, using Ignite's service grid could be a good solution. May not work in all cases, okay, that's the nature of technology, but certainly it's worth having a look at, and that's the goal, to inform you and to give you a choice and to help you decide if it's suitable for your needs. Okay. Other things then, so common pitfalls, then of course we need to think about lifecycle management. You know, how long are these services going to run? Do we want services to be running continuously and all the time? Or can we specify some time of lifetime for them to say, okay, run for this amount of time and then you stop, you know, no, we're no longer required. And of course, in terms of communication, well, if you're going to run these on Ignite, then of course Ignite can manage that layer for you. Fault tolerance, load balancing, again, the same principles apply regardless of whether we're storing data or we're running services. We need those same capabilities that Ignite needs to perhaps fire up some additional resources. Maybe if a service has gone down somewhere, Ignite needs to be aware of that. It will try and launch that service again for you in another part of the cluster. And then, of course, scale. Part of the reason that you probably want to use cluster computing is really to give you some degree of scalability, the ability to store more data, be able to process it in parallel, and give you sort of better performance as well. Okay, so data layer, computational layer. So one of the nice things about Ignite is that this kind of basic compute grid, as it's called, when you know, it's one of the core components and one of the most mature components of the technology. It offers this kind of fork join. So if you're familiar with how Java works or MapReduce, it's the same sort of approach. That basically, as work comes in, it looks to see what resources are available. It divides that, sends them to the appropriate nodes. They each do a part of the work, send it back. It's combined, sent back to the client. Okay. So here is a kind of rough sort of architectural diagram, rather simplistic, but let's look at the components for this. So we may have at the top there external applications that use microservices, okay? And then within the cluster itself, we've got two types of nodes, okay? We've got data nodes, or server nodes as they're called, okay? They just store data. Okay, and that data could be replicated. So we may have a copy of the data on here. It may be replicated on another node as well. And then those nodes contain other parts of the data. So the overall data that we have stored in our cluster is divided up. It's spread across the cluster. And if we've decided we want to keep backup copies, then again, that can be done for us. So in the event, for example, that we lose a part of our cluster, let's say this node goes down, because the data are replicated elsewhere as well, we can still do work, okay? All of the data is still available to us. The other type of node that we can run is called a service node. And here you can see a number of these MS, microservices that could be running, okay? So we have MS1, MS2 running on this service node, MS1 possibly running on that one, and then the last one, MS2, MS3. Now, this doesn't mean that we've got multiple instances of these services running. It just means that that node is a potential, somewhere we could run a service. For example, if we define a cluster singleton, let's say MS1 is a cluster singleton, only one copy of it may run across our entire cluster. We may run it on this first node. But if we look here, we can see that MS1 is also defined for the second node. That means that in the event that this goes down, that node can take over, okay? We have the ability to configure Ignite in such a way to say, okay, here are sort of, if you like, additional nodes that you can use for running this particular service in the event that, say, where you're currently running it goes down. Again, the demo will show you how we can do this, okay? Other things, right, so persistence. Now, I talked about third-party persistence, so relational databases could be used, but here we can see some examples of NoSQL databases, or we could use HDFS if you want. Its own native persistence, that's possible as well, okay? So in the event that data needs to survive much longer beyond the lifetime of the process that created it, we've got a range of options to work with. Okay, so let's quickly look at the Ignite nodes. Okay, so data nodes, okay, also known as server nodes, act as containers for data and computations, generally started as standalone processes, and there's in the demo I'll show you how to do this. So basically, it's a node that you start up. It stores some portion of the data, the overall data in your cluster, and it can do some compute tasks as well. Okay, you can run some compute jobs. Client nodes are what we connect to the server nodes. They request some task, some work to be done by the cluster, and these are totally separate. Okay, so this gives us a way to be able to run jobs on our cluster. And of course, in the microservices environment, as we saw in the previous diagram, these could be applications that have absolutely no knowledge of Ignite, don't know anything about the cluster computing, but they have access to a well-defined interface that we've got. They can request their services, send them to this interface, get back results, and they don't care where these services are running. That's okay. I mean, that's perfectly possible, and a good way to do it, actually. All right. Other things from here, so public and private cloud. So Ignite will run pretty much anywhere. It's a Java-based system, but it also has interfaces for C++, .NET. These are high-level languages that are really well supported as well. Other languages, if you're working with them, then it's JDBC, ODBC support generally. And there is this thin protocol which is being used to develop interfaces for additional languages. Okay, so here we go. Server node stores data, runs queries and computations. We mentioned that already. Plain distributed storage. One of the other nice features about Ignite is that typically when we're, say, in a testing environment where we want to be able to test code, test services, there's a great feature, it's called peer class loading, which is very useful because what it does is that the developer can modify the code, change it. You can push the code out to the servers. You do not need to restart the cluster. The cluster becomes aware of the code changes and can apply that code directly and immediately. So when you're testing services, you're testing your code, for example, this is, again, very helpful to you because if you've got a particularly large test cluster, then bringing this down and starting it up again can take a little bit of time, all right? And if you're doing that frequently, a lot of your time is simply spent shutting the cluster down, bringing it back up again. Use this with care. With great power comes great responsibility. So as you can see, peer class loading is great. In a live environment, probably you don't want to be pushing code changes out very frequently, okay? And it's a simple common sense thing. We are human. We make errors. Our code can do terrible things sometimes. So in a live environment, we might write code that does a certain function, but we missed, or didn't test it properly, or there's something we forgot to do. Our data may be affected cluster-wide. It's a very risky thing. Powerful, but used with care. Okay, so again, something that's very useful, but be careful how you use it. Okay, so quickly then, so code definition. So basically a lot of the characteristics and the what we want to specify is the behavior of a node. We can do so through these XML configuration files. Okay, so here, for example, we've specified that this is going to be a data node. Okay, and we're going to filter just on data nodes, for example. In our code, we can just refer to it as check the node attribute. Is this a data node? Then it just stores data. It will not run a service. Similar sort of setup that we can do if I just move forward here with services as well. Okay, let me just show you this. Okay, so there we go. So here we've specified that this is a service for this particular vehicle service that we've defined. And we've specified this again within the XML configuration. So when this node starts up, it knows exactly what it's supposed to do, whether it can store data or can run a service, all right? Very, very useful. And then, of course, there's a lot of other parameters that we can specify and configuration details that we can set up. And then in terms of the interface itself, okay, this is some example on the right-hand side. I'll show you the code in just a moment, how we can do this, okay? So this is a well-defined API that's available both for the service nodes and applications. They know exactly what services they can call, what results they can get back, okay, because it's all well defined for you. And then, as I mentioned, typically if you're building external applications, you may not know what, how Ignite is configured. It's not of interest to you. All you're simply interested in is requesting some service, some behavior, and you can access using sockets or REST or some other sort of loosely coupled protocol if you want. Okay, we've seen this already, all right? Okay, so I think we've done this already. All right, we've covered that already. Persistence, right, so we talked about this already. So you've got a range of options that you can use. And Ignite can do read-through and write-through from external persistence for you, okay? And if it's a transactional system, such as a relational system, it will ensure consistency both in terms of the cache and the relational system because it's transactional. For a lot of these NoSQL systems, they work slightly differently, okay? They are eventually consistent. So unfortunately, Ignite cannot guarantee that the cache and the backend will be the same, okay? So very, very important here. But read-through, write-through, again, it's available. Okay, so let's just have a look. I think I'm almost out of time, so very quickly, let me just show you the demo, and I will tell you where you can get this demo, okay? So if you have a look on GitHub, okay, and then just go to Magda, okay? If you can see that, there we go. Dennis Magda, okay, Dennis is my boss. And then just look at his GitHub space, okay? So that's github.com, dmagda, and you'll be able to see on here microservices example, okay? So it's a full sort of project that you can download and have a look at. It's got a pom.xml, just load it into your IDE, okay? And so I've got the example here, and there we go. So let me just blow this up a little bit, okay? So what we can do from here, so I've just loaded it up, just read it in. Okay, so I'll start a data node here. Okay, so run this, and that should come up straight away. And then I've got a couple of these services defined. One is for sort of maintenance of vehicles, okay? A maintenance service node. And this node knows exactly that it's only able to run services. It will not store data. So I've run an instance of that one. And then I've got another vehicle service node which does something slightly differently. I can run an instance of that. Again, it knows through the XML sort of configuration that it's a service node. It can do this particular service that is defined. Okay. And then I can even run an external application which knows nothing about Ignite or the cluster or anything, but it can use REST or a socket to connect and do some work. And the implementations for these are just down here. So here's the maintenance service implementation. Okay, the API is defined, what methods we can call, and what it will return. And similarly for the vehicle service implementation there as well. And again, what we have at the top are these XML configuration files. Okay, so they contain the information. So As the node is starting up, we are pointing it to a particular config file. The config file contains all the details about the service, what role this particular node has, and the node, as it's starting up, just pulls the information. It knows exactly what's going to happen, okay? And let me just kind of wrap up then. Let's run this external application, and then we can see, try and get some results. Okay, so here, it's just querying our system, and we're just running across this, and this is the maintenance schedule for a number of vehicles, for example. Okay, thank you. And what we can do is, let me just go back here, and we can run this one. Okay. Okay, there we go. Let me just run this one, okay. Okay, there we go. So I've got a couple of different nodes running there, okay? A couple of service nodes, a standard data node, a couple of applications, happily running within the IDE, all right? I mean, my machine hasn't got an enormous amount of memory, but for this particular demo, it's okay. So this external application, what it's done, it's changed some data. So you saw that list of vehicles just a moment ago. What I've done is I've updated something here now. And so if I run this external app here, I should see some data has been modified. Can you see, look, this one here, maintenance of this particular record has been updated by this application. That's fine. Now, with this maintenance service node I've got running here, I've got one instance at the moment, okay? That was what was specified, and I can check that by just going back here, and you can see there is a bit of information here that tells us there's only one instance of this is going to run. That's fine. Now, let me launch another instance of this. Okay. All right, just give that a moment. There we go. So this one is running, but as you can see, there's no information here about the service. The service is not running because we specified that that service, cluster-wide, is only going to be one of them. So we've got two of these nodes running that know that they are supposed to run this service. Remember the diagram I showed you earlier? So the configuration, Ignite knows there's already an instance running. Okay, I've powered up another node that can potentially run that service, but it's not running that service because we only need one instance, all right? If this node that's running this service here crashes for some reason, and I'm going to stop this node, all right? So now it's crashed. Let's say some part of our cluster's gone down. Let's switch over and have a look at this other one that we launched just a moment ago. Can you see that it's now picked up and now running that service there? So automatically there's failover, all right? So one cluster-wide implementation of that service, one instance that we want, our node's gone down, but the configuration that we've set up means that if we lose a node, Ignite will automatically switch, start that service on another node for us. Okay, so that's a great example of a singleton. Okay, and again, have a look at this in your own time. This is pretty basic stuff. Java. It's all implemented in Java and fairly straightforward. It's a fairly small, self-contained project that you can play around with. Have a look at the configuration files. Okay, so all the configuration that you want to set up, very easy to do, and then equally within the examples, you can have multiple data nodes running as well if you want, and these test applications, which are external. Okay, so they know nothing about Ignite, but they know the API that's available, and they can work to that API. So there you've got some flexibility, separation between what the cluster is doing and what your external application is doing. Okay, great. So I think I'm out of time, and so let me just wrap up by saying that feel free to reach out to me on LinkedIn. Okay, so this surname is spelt many different ways, so be careful. All right, you can make sure you get to the right one of me. Someone asked me, is that really your job title? Rockstar Tech? It is. So I'm on Twitter as well, okay, if you're into social activity. Okay, and then the landing page for Ignite. This is a great resource to go to. The dev and the user list are very, very active. I believe Ignite is amongst the top 5 most active Apache projects today, both in terms of contributions and the activity on the user and dev list. So if you've got questions, sign up. Don't be afraid to ask. There's enormous amounts of help available. Even basic questions, simple things that you want to ask, there's fantastic resources available. They'll dive straight in, assist you as best they can. So it's a great way to learn about the technology. The documentation and everything is available as well. And as I said, so if you want this particular microservices example, just go to Dennis's GitHub page and you can download it. Okay, great. So any questions?
Are there any questions right now?
Any questions, any issues, any concerns? Okay, probably you guys have
Thank
had
you very
enough.
much then.
One question. Okay, great.
So is it possible to mix different back-end persistence technologies?
Right.
Like RDBMS for certain things,
Yes.
and then NoSQL or...
Okay. Okay, so the gentleman, the question asked was, can you mix the backend technologies? For example, could you use both a relational system and say a NoSQL system, or Hadoop or HDFS? The answer is yes. So in theory, you can combine a number of these technologies together. Ignite's behavior, though, may be undefined. It's hard to predict, though, because if you're using just a relational system, for example, that's transactional, then Ignite, for example, it will guarantee the consistency between its cache and the backend. That's guaranteed for you. If you're working with a NoSQL system, it cannot guarantee that because these systems work a different way. And if you're going to combine the two or more together, and again, the situation is kind of unpredictable because it depends on what parts you want to update in one system, what parts you want to update in another. I think through code you could achieve it. It's possible. Natively, whether Ignite supports that, I'm not sure. I can check that for you. It's a great question and a kind of a tough one for me to answer, but I can find out for you. So, yeah.
I can give a little more background information. Yes. So in my day job, we use Oracle.
Okay.
And the architecture, the relational model has been a little bit compromised in order to achieve high search performance.
Right.
And maybe it would be possible to achieve good performance with a good cache like Ignite.
Okay.
But sometimes we think about using a different technology for the read-only part.
Okay.
Like not using database views anymore, but using something like Elastic or something
Understood.
like that.
Okay. So in that case, then it might be rather than using Ignite, and I'm only doing this to trying to help you because I feel that there are cases where Ignite will be really, really useful and other cases where it may not be useful. So I would definitely look at alternatives because I think using Ignite is great as a caching technology. It's great working with transactional systems. It's great if you're working with NoSQL but not concerned about the transactional part. So if there are some queries that you want to scale, say from your Oracle system, but you're looking to kind of effectively replace the Oracle, some parts of that, or what Oracle is doing with some other technology, it might be better to look at alternatives. Ignite might help, might not help. I think need a bit more information about the specifics, but certainly in terms of two backends, that's something I can investigate for you and be happy to follow up with you. Feel free to drop me an email. And by the way, my email address, firstname.lastname@gridgain.com.
We have to wrap this up at this point.
Yeah.
But thank you very much
My
for
pleasure.
being
Thank
here
you.
today.
Okay, great. Thank you.